Let's take a look at a specific type of simple machine, the lever. Now let's see that again, this time in physics motion. I want to lift that there box high. Looks like the ceiling's too high. I'll settle for 0.38 meters from the floor. Wonder how much work that would be. Well, let's find out. As you'll remember, work equals force times distance. Now the force is the 400 newtons down in the corner here. That's the weight of the box, the force of gravity pushing down. 400 newtons. We have to counteract that if we want to lift the box upwards. And we want to lift at 0.38 meters, 0.38 meters. So force times distance. We multiply those together and we get 152, look at the units, Newton meters. They don't cancel, so you just multiply them, Newton meters. But the Newton meter, while it's important, isn't the way, it's kind of ugly, it's kind of bulky, it isn't the way they want it to look. So they decided to officially abbreviate Newton meters, or write Newton meters as the letter J, joules. Joules, J-O-U-L-E, joule. So 152 joules is how much work would be done if we were to lift this 400 Newton box. Dangity dang dang dang. Heavy old 8-cornered beast. Wonder how much work I did. Sure felt like a ton of work. Well, let's figure out how much work he did. Work equals force times distance. Let's just assume he put out at least 400 newtons of force. Though maybe he didn't, maybe that's why he couldn't lift it, but let's just give him the benefit of the doubt there. You'll see it doesn't matter, because how far did he succeed in lifting it? Nowhere. 0 meters. That 0 wipes out the 400 and you end up with 0 joules of work, which is a really, really, really important point. In work, you have to succeed in moving the object at least a little distance. It is force applied over a distance. So if you can't move the object, no work was done. A lot of force might be put out. You might have sweated a lot. You might have worked really hard from the standpoint of how we usually use work in our language, but in the scientific sense, no work was done. I have an idea. Behold yon fulcrum. A fulcrum is the center of a lever, the support on which the lever hinges. Let me show you. So how much work will I have to do with the lever? Well, let's find out. Work equals force times distance. The force is 400 newtons. The distance the lever is going to lift it, 0.38 meters, 0.38 meters. Well, that's going to come out to our old 152 joules. That's right. That's important to realize. The amount of work done, whether you're lifting it by hand or lifting it with a simple machine, is exactly the same. The amount of work done is exactly the same, whether you lift it by hand or lift it with a machine. The same amount? Then what's the point of a lever? Well, I ain't changed the height and I ain't changed the work. So it must be that the force I need to apply is less. Let's find out. Yep, way less force than lifting it by hand. If we were to take a look at exactly how much force, it might be informative. So let's figure this out. Work equals force times distance. So the work involved, we now know, is 152 joules. The force is what we're looking for. And the distance this time isn't how far up you would lift the box. It's how far down you had to push the lever. And the lever went up a little more on the left-hand side than on the right-hand side. It was a little taller, a little longer, went up to about his knee. I'd say that's about half a meter. So now force is going to equal 152 joules over 0.5 meters. Equals, here, let's put the force there. Now that's going to come out to be 304 joule meters. Well, what's a joule meter? Well, it's paid sometime to know that a joule is a Newton meter. You can break it down into a Newton meter again. 304 Newton meters divided by meters, and you can see that the meters cancel, leaving you with 304 newtons, and newtons are the unit of force, so you know you probably did this right. Now compare that. 304 newtons of force needed to lift the box with the lever versus 400 newtons lifting it straight up with your muscle power on your own. So with the lever, it's 304. Lifting it by hand, it's more. It's 400. And that's the way it works. Work equals force times distance. Think about this. If we always knew the work was 6, and the force we put in was 3, and the distance was 2 that we lifted it, well, if the work stays the same, but the force goes down, like in the case right over here of using the lever, if the force goes down to a 1, look what has to happen to the distance. It has to go up to a 6. So when the force gets smaller, the distance gets larger. That's very important to realize. What a machine does is it lessens the force you have to put in by increasing the distance over which you move that force. In the case of the lever here, this distance is shorter than this distance. So you do more distance when you use the lever than if you just lifted it. And by using more distance over which you apply the force can go down. So instead of the 400 newtons, which is that way, the 304 is this way.